Okay. Yeah, I make it quick. We are some minutes after plan. About adaptive life, about the Stein application you are using all this conference and using with great success because we never had so much questions that you provided us this year. It's really great. So the idea for this application was born in the pandemic because in year 2020 and 21, adaptive was virtual. Unfortunately, we had no other possibility to make it. And this was not nice. The community was missing. It was very tiring with all those virtual videos 3 days long. But the talk tooling was very great, which we used there. So there we experienced how great it is to have a chat and especially this Q&A tooling. And we wanted to get this good part of the pandemic and use it in our live conference as well. And therefore, we no longer need our guys with those micros handing around, which also took a lot of time and it was not so convenient. So it's really working great. And also, thanks to all speakers who have answered even nearly all questions which were not answered in time here, asynchronous in the app. So please all go into the application. It will stay up for quite some days. And we will publish this Q&A stuff later on our website as well. So it's not lost because a lot of valuable information is there. So the goal when we started to implement this adaptTo live was digitize the rating evaluation process. It's the second very important thing for us. Rate every talk, please, and use this evaluation sheet as well. It does not contain so much questions. It's really quick to answer, and you do not have to fill out all text boxes. They're all optional. But if you feel, then tell us what you think. QA handling was important. We wanted to provide this chat. This was not so important. Maybe make this QA handling a bit more prominent in the future. Lobby for general support was what also a bit used, and especially have an easy login, low entry barrier with this cards. I think this worked quite well as well. We had nearly all participants here registered in the application at some time. Architecture about is, it's a completely Node.js application implemented by myself. So if you see the code, don't blame me if I'm not implemented the best code, but it worked very stable. I was very happy about it. So on the back end, we have a MongoDB and a Node.js server. And on the client side, it's just a Vue.js client single page application, and the communication is completely done with WebSockets. So this whole application is not doing any HTTP GET or POST call. It's completely using WebSockets with all this eventing happening, and it's working very great. We have a slight integration to our Franklin website, pulling the agenda live from it, which talks exist, and just a link to this Llama poll evaluation sheet using the same code like you used for login. And tech stack, as I said, Vue.js Socket.io is a super cool library for doing WebSockets, working both on the client and on the server with nearly identical semantics. It's super use. Bootstrap, TypeScript, usual stuff. Mongoose is also cool. It's an object document mapper for MongoDB on the server. It's super neat, especially with very good TypeScript support and a bit of validation. And just to show you how Socket.io is working, if you've never seen it, this is on the client side. So if someone enters a room, so just switches the room in the UI, we just say, okay, emit a message, room enter. This room enters message was defined by us and had a set of properties. For example, in this case, which talk was entered with ID. And then if you just put in a chat message, we will just emit another message with chat. And if other people send messages, then we react on incoming messages and just display in the text box. It's really super easy and works quite well. And we can handle cases where you update text, where you quick fix some typos in your messages and so on, or questions answered. Super easy, works very well. Server side, it looks nearly the same. You have a socket which reacts on any room enter event and then has a response handler. So first it joins a room, so a special room concept in Socket.io, which fits perfectly to our different talks. So each talk has its own room in Socket.io. And then first we send the new entering user all existing messages, and then we just react. If we get a message event, then we just emit it. Of course, we store it also in the database. This is missing here, this code, but it's super nice. And when I started implementing this stuff, 3/4 of the functionality was really working with just 20 lines of code or so. And of course, it got more complex now with all validation and so on. But the first running prototype really was a very, very small bunch of code on the server. So it was really really cool. And of course, I wanted to make sure it works with 200 people. So I did a bit of load testing, and I found Artillery is a load testing tool which also has support, quite simple support for WebSockets. So you see here, I'm missing the part where how many users are used and so on. Just I have a simple text file with a lot of ratings, for example, and it picks by random one for each use case. Then I connect with the server via WebSockets and just emit a talk rating event, for example, in this case for a random talk ID and a random rating, and check that the response is successful. And that's it. With this, I can really very easily simulate lots of users, and it works quite well. And also, all this takes not a lot of resources. We are running in Asia, but with a very small program for CPU, and also running Cosmos DB in serverless mode. This is a very cheap mode because it's not constantly available, but only scaled up and down when you have actually requests. It's limited with 5,000 request units per second, but we were not near to it as far as I've seen. So really cool stuff. And if you want to see the sources, of course, it's all open source, Apache license. So if anyone want to reuse it or just look into it. It works very well. Yeah, 10 minutes. Oh, we are in time back. So.